And welcome. My name is Ibrahim Abdusalam, and I'm a petroleum geoscientist by practice and as well as by qualification. Today, we'll be talking about understanding production data for geoscientists. So, typically, as a geoscientist working in some company somewhere, one thing is imperative, and that is if you do not work in probably an exploration unit or probably geology and geophysics operations units, you may most likely find yourself in what companies call the asset teams, and these are teams that are saddled with the responsibility of managing assets. And in this case, we're talking about the fields that these companies are operating. And typically, these teams are usually multidisciplinary teams. And it is very heavy on cross functionality, I beg your pardon, meaning that you have several disciplines within the same team, maybe production engineers, reservoir engineers, you may have laboratory technologists, petrophysicists, earth scientists, and the list can go on and on. But the key thing here is that you're working in a cross functional team. And situations will warrant where you have to understand things that the engineer is saying or the petrophysicist is saying. It is not fair enough for us to say that we are geoscientists and we just restrict to our shells and all we know is fault and maps and all of that. Because in an asset team is typically cross-functional. Yeah, I'll reiterate, it's usually cross-functional. So there is huge need for us to understand what other functions are saying so that we could work together to provide value to the companies or whatever companies that you may be working for in the time soonest from now. This session is going to be more of a hands-on session where I'll be showing a couple of data sets and how we derive some information from these data sets. So stay tuned and let's get to it.
All right, so let's get to it. So after a discovery has been made, it's been appraised, decision has been made, and production starts. So basically, in the most conventional of terms, or more popularly, production usually starts very low and slow, then gradually builds up, and after a few months or years, it stabilizes, plateaus for a period of time before it starts to drop or decline, and before it reaches its economic limit, and before abandonment takes place, right? So as a production geologist or somebody who works in the asset team as an engineer or whatever we have, your aim is to make sure that production does not drop. You want to optimize production as much as possible, and in optimizing production you need to understand certain things, and certain things that you need to understand will be things coming from cross-functional colleagues, be it engineers or petrophysicists, and this is why you have to have an understanding of what production information or what production data is saying. So next up, we'll be taking some few examples of what production data looks like and how we can make a bit of meaning out of them, basically. Okay, so this is a production profile, and this is something that when we as geoscientists, when we get to see such things, we may start to get nervy and start to push back that, oh, I'm not an engineer. But then it's pretty simple. So the first thing we need to understand is that the colors, the green is actually oil rate, the blue is water cut, and the red is GOR. So pretty simple. Oil production rate is just the amount of oil you've produced. GOR means gas oil ratio. Produced GOR in this case means the ratio of produced gas to that of oil. So produced gas over produced oil, the fraction you get is the GOR. Lastly, water cut or BS&W just refers to the amount or the fraction of water that you produce from the total barrels you've produced. Say for instance, you produce 100 barrels at 0.2 zero water cut. So what that means is that you produce 100 barrels and 80% of that, or those barrels you produce, is oil, while 20% of it is actually water. Right, so in this case we have GOR, water cut, and rates plotted against time. So we see the interval. This is from 0 years to 5 years, 5 years to 10 years, 10 years to 15 years, 20. So 5 years interval as we move towards the end of this plot here. So what it tells us is that oil rate started off high at about almost 6,000 barrels per day, but within 10 years it started to drop and water spiked up basically. So this tells us that we were only able to optimally produce from this field for just roughly about 10 years before we started seeing water. And as a petroleum geoscientist, you are not after water, you're actually after oil, right? So you see the water climbing up, but GOR, gas, was actually kept constant for a very long time at a very low rate basically. So typically this tells us that at some point probably things were not probably paid so much attention to, and we had a lot of water breakthrough, or this could have been what was forecasted from initial stages, that after 10 years we begin to start having high water cut. And of course, when you have high water cut, your daily production rate would definitely drop. So this is just a quick analysis of what a production profile looks like. Next up, we'll be looking at another data set. All right, so what we have here is another data set that you might be utilizing in a cross-functional team. So this is a pressure plot, and we have depth in feet against pressure. So depth on the y-axis and pressure on the x-axis. So typically from here to here we have the gas gradient, from here to here we have the oil gradient, and from here to here we have the water gradient. So whenever you see a gradient of 0.05, 0.09, what it's telling you about is actually a gas gradient. And when you see that of maybe 0.30, 0.35, it's telling you about an oil gradient. And when you see that of greater than 0.40 roughly, it's telling you about a water gradient. So things we could actually get from a pressure plot, I beg your pardon, are we could tell what area of our reservoirs may be saturated with oil, what area may be saturated with gas, and what area may be saturated with water. So in this case, we could tell that from here to about here we might be having a gas saturated area. From here to about here we might be having an oil saturated area, and from here to about here we definitely have water saturated areas. Another thing we could infer from this data set is contact. So at the point where the trend line of the gas intersects with that of oil, we might be having a GOC at that point, and where that of oil intersects with water, we may be having an OWC at that point. Typically from the reservoir engineering point of view, they actually use it to calculate what we call the P datum, or the average current reservoir pressure, but that is another scope of things. Next up, we'll be looking at one last data set that we might be utilizing in cross-functional teams, and stay tuned. Yeah. All right, so this is another data set that is used. Typically, this is more of a production engineering thing, core and core. So here we have what we call the VLP IPL cross plot. So on the y-axis we have what we call PWF, meaning flowing bottom hole pressure, and we have rate, production rate, QP, production rate. Then we have IPR and VLP. VLP stands for vertical lift profile and IPR stands for inflow performance relationship. So IPR, what it means is that it accounts for the relationship between the reservoir and the perforation, while VLP accounts for pressure drops that happen as the fluid or the crude moves from the tubing to the surface. So typically the key thing here to know is that what they look for, the engineers look for here, is what we call the OC, operating condition, and this is where the VLP and IPR plots intersect. So you have the operating condition, and an operating condition simply means that it is at that temperature and it is at that pressure that you'll be able to operate that well at a safe condition that would not hinder the well or the reservoir. So basically that's what it is. So these are certain analysis that are done that will be communicated to you as that production geoscientist, and you must be able to knot data points together to actually understand and provide value. Thank you so much for listening, and bye bye.